We live in an age of some pretty incredible power. I mean, we can level entire cities, we can reshape landscapes, and that leads to some pretty big and honestly kind of scary questions. So today, we're going to tackle one of the biggest ones. With everything we've got, could humanity actually break the Earth?
I mean, think about it. Could a full-on nuclear war, like our absolute worst-case scenario, have enough brute force to just knock the Earth clean out of its orbit, send it flying off into space? It sounds like something straight out of a movie, right? But what does the actual science have to say about that?
Okay, so before we can even begin to answer that, we need a serious reality check about scale. We humans, we tend to see ourselves as the center of everything, don't we? But to really get a grip on our actual power, we have to zoom out. I mean, way out.
So let's just start with pure physical weight. The mass of planet Earth is almost 6-septillion kilograms. That's a 6 with 24 zeros after it. Now, the mass of all 8 billion of us humans combined, it's around 400 billion kilograms. That sounds huge, right? But when you put it next to the planet itself, we're not even a rounding error. We're barely a whisper on the scales.
Yeah, this quote just puts it perfectly. Trying to move the Earth with our own mass, and that includes all our cities, everything we've ever built, it's like adding one single drop of water to the ocean and asking if you've changed the tide. We just don't have the heft.
All right, fine. So our mass is nothing, a non-factor. But what about our punch? What about pure, concentrated energy? Surely the atom-splitting power of a nuclear bomb, that's got to make a dent, right? Well, let's see.
The bomb dropped on Hiroshima was about 15 kilotons. Just a few years later, we built something called the Tsar Bomba with a yield of 50 megatons. Now that's not just a little bigger, it's over 3,000 times more powerful. That is a terrifying leap in destructive power.
But here's the number that really truly matters. This is Earth's gravitational binding energy. Basically, it's the amount of energy you would need to completely blow the planet apart, to overcome the gravity that holds all of that rock and metal together. Just look at all those zeros. It's a staggering number.
So, how does our biggest punch actually stack up against that? When you compare the energy of the most powerful bomb ever made to the energy holding our planet together, you can't even see the bomb's bar on the chart. It's not there. Its energy is just 1/quadrillionth of what you'd need. It's nothing.
And that's really the bottom line, isn't it? It's a pretty humbling thought. All our sound and fury, our most powerful and terrifying inventions, they amount to nothing more than a tiny firecracker against the planet itself. We simply can't break the rock.
Okay, so if we can't break the Earth, can we at least nudge it? I mean, what force is powerful enough to keep this entire planet locked on its path, flying through space at 67,000 miles per hour? The answer, my friends, is 93 million miles away. It all comes down to this fundamental law of the entire universe, first figured out by Isaac Newton. It's gravity. It's not a suggestion, it's the rule. And the strength of that gravity all depends on one thing: mass.
And in our little corner of the universe, when you talk about mass, you're talking about the sun. It contains 99.8% of all the matter in our entire solar system. The planets, the asteroids, you, me, everything. We're all just part of that leftover 0.2%. The sun doesn't just dominate the solar system. For all intents and purposes, it is the solar system. Its gravity is an unbreakable leash.
People sometimes ask, hey, don't our rocket launches push the Earth a little bit? Well, technically, according to physics, yeah, they do. But the effect is so ridiculously infinitesimally small, you can't even measure it. This analogy just says it all. We're jumping up and down inside a massive, high-speed train, thinking we can somehow change its course. We can't.
So it's pretty clear our power is insignificant on a cosmic scale. So what does a real planetary threat actually look like? Let's put humanity in the ring with a true heavyweight champion from Earth's past.
In one corner, you've got humanity's biggest punch, the Tsar Bomba. And in the other corner, you have the Chicxulub asteroid, the one that slammed into the Earth 66 million years ago. That impact released the energy of billions of nuclear bombs, all at once. It triggered a mass extinction that wiped out the dinosaurs and 75% of all life on the planet.
And here's the real kicker. An impact that powerful enough to end the entire reign of the dinosaurs, to completely reshape the evolution of life on this planet, even that was not enough to meaningfully change Earth's orbit around the sun. The sun's leash held firm. And that brings us to the most important point of all of this. We've established that on a cosmic scale, we're basically powerless. But that doesn't mean we're harmless. Not at all. It just means we've been aiming our power at the wrong target.
So let's just get this straight. The things we can't do, we can't change the orbit, we can't break the planet, we can't mess with the solar system. But the things we absolutely are doing, we are changing the thin, fragile layer of atmosphere and water that keeps every single one of us alive. We might not be able to move the rock, but we are absolutely capable of poisoning the garden that grows on top of it.
See, our real power isn't astronomical. It's biological. We're not strong enough to move the planet, but we're more than strong enough to rewrite the chemistry of its oceans and its atmosphere. We're a geological force, sure, but one that acts on the biosphere, that incredibly fragile film of life that just coats this giant rock.
So you see, in the end, we've been asking the wrong question this whole time. The Earth, the big rock itself, it's going to be fine. It'll keep orbiting the sun for billions more years, with or without us. The real, urgent question we need to be asking ourselves is about us and about that delicate life support system we completely depend on. And that, well, that's a question we don't have a clear answer to just yet.